Hello students, so today we are going to learn how to calculate empirical formula and molecular formula of a compound when the percentage composition of different elements in that compound is known and also the molecular mass of that compound is given. So here we are taking this example from the book NCERT, and this says a compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine, and its molecular mass is 98.96. Then what is the empirical and molecular formula of the compound? So right side here I have written the atomic weight of these three elements which are found in this compound: hydrogen, carbon and chlorine. So that I will use in this question, that will be used here. So let us start and let us see how can we proceed for this question. So there will be three steps for determining the empirical formula. So let's write the step 1 first. So in step 1 we consider 100 gram of that compound. Consider 100 gram of compound. So if you consider 100 gram of compound, then percentage composition of each element is given. And one more thing you can notice here, that sum of all the percentage numbers given, that must be 100. So 4.07 plus 24.27 plus 71.65, that should make up total 100%. Sometimes only two percentage values are given but not the third one. Then in that case you can sum the two numbers and subtract that from 100, then you will get the third element percentage composition. So here all the three elements percentage is known, so we don't need to worry. So okay, let's move. Consider 100 gram of compound. Then in 100 gram of compound, according to the percentage composition, we will have 4.07 gram hydrogen, 24.27 gram carbon and 71.65 gram chlorine, right? So next step, step 2, that will be to determine the number of moles. So number of moles of each atom in that compound. So 100 gram we have considered of that compound. So in that 100 gram of compound, how many number of moles of each atom will be? So number of moles of hydrogen will be 4.07. How do you determine the number of moles? You determine the number of moles by dividing the mass by atomic weight. So 4.07 divided by 1.008, and this will be your, if you will divide this, you will get 4.04. And similarly next will be 24.27 divided by atomic weight corresponding is 12.01. So here you will get 2.02, and the third one is 71.65 gram chlorine and its atomic mass is 35.453. Sorry, 35.453. So this you will solve 35 to this will come 2.02 again. Okay, so now we have the number of moles of each atoms in that 100 gram of that compound. Okay, so what will be next step now? Now we will calculate the relative number of moles. So let me write that is the step 3. So now we will calculate relative number of moles. So how will you calculate the relative number of moles? You will choose the smallest number in the last step we have calculated. So there are three numbers we are getting: 4.04, 2.02 and 2.02. What is the smallest of all these? This is 2.02. So you will choose the smallest number and you will divide every number by that smallest number. That will give you a relative number of each element in that 100 gram of compound. So it will be a relative number of moles. So for hydrogen, it will be 4.04 divided by 2.02. So this number will be 2. For carbon, it will be 2.02 divided by 2.02. This will be 1. And for chlorine also, it will be 2.02 divided by 2.02. This will be 1. So we have 2 atoms of hydrogen, 1 atom of carbon and 1 atom of chlorine. So what will be empirical formula? Now we can write. And what is empirical formula? I think you know that empirical formula is simply a formula where you represent the simple ratio of each element found in that compound. So here we have three elements: carbon, hydrogen and chlorine. So what is the relative number? Simple ratio. So carbon is here, we calculated relatively 2 atoms. hydrogen is 2 atoms, carbon is 1 atom, and chlorine is 1 atom. So C is 1, H is 2, chlorine is 1. So we don't write the number 1. So this is your simple ratio of each element found in that. So CH2Cl, that is the empirical formula. So first step of our question is done. Now we move to next step. What is next step? To calculate the molecular weight. So we will write step 4. So molecular formula, how that we will calculate. So molecular formula is similar to the empirical formula, like CH2Cl we have calculated, but here each subscript, so each suffix number here, that will be multiplied by a whole number. And what will be that whole number? N. That how can we calculate? That is calculated by dividing the actual molecular weight of the compound divided by empirical formula weight of the compound. So empirical formula we have calculated just now, CH2Cl, we will take that weight and we will divide by that weight the actual molecular weight. So here N will become, molecular weight of the compound is given in the question, 98.96, and divided by what will be the empirical formula weight. So carbon is 12.01, that is known. Hydrogen is 2 into 1.008, and plus there will be one more number, chlorine, that will be 35.453. and if you will divide this all 98.96, and let us see how much this total will be. So it will be 12.01 plus 2.016 plus 35.453. So this is coming 49.479. 49.479. If you divide it, 98.96 divided by 49.479, you will get 2. So this is small n whole number, that is 2. So what will be the molecular formula now? That will be CH2Cl. That was our empirical formula, and we will multiply each subscript by number n, which is 2. We now know about that. So just multiply each subscript by 2. So it will be C2H4 and Cl2. So this is your actual molecular formula of the compound, C2H4Cl2. So I hope you have understood this problem and the 3 or 4 steps involved in the calculation of empirical formula and molecular formula. So if you have liked this video, you can consider subscribing my channel and sharing this video with your friends also. So we will meet again with next time with some other problem, and till then, take care, bye bye, and thank you very much.